Hello everybody, welcome back to From Rhythm to Algorithm. We continue on with our derivation. What does sensorality stabilize? A sensei is a virtuoso. Or I have what is a sensei to a virtuoso. But last time we finished up with the linguistic similarity of viscosity to virtuosity. You can hear the rhyming. I'm looking to show this fundamental differentiation, the direct iteration of the syllability sensorality. What is a sensor? What is sensation? Why does my microwave say it is a sensor with an S, but it does not have senses with an S? So that is our fundamental discrepancy, our inconsistency that we are resolving with our linguistics. But right, a sensei is a sage, they are wise. A virtuoso is extreme competency. They are very capable. What is virtue to accuracy? Memorality stores virtuosity. What is voluminosity to virtuosity? What is generosity to virtuosity? Is generosity a virtue? Again, explicitly relating some of these more expanded concepts that you've used, volume, voluminous, but you probably haven't heard somebody explicitly say the base of volume is voluminosity. Volume is bright, directly, literally. And so emphasizing the word forms where they are relevant. But the entire progression of this whole derivation is the word forms progressing. Is consistency relevant? Relevance is pertinent. Again, pointing out if I ask a question at the rhetorical woodcock, and if I just say two words, I'm just comparing the concept and the syllability. How does this sound with this meaning relate to its word form? And then how does that word form relate to other words? Relevance is pertinent. Sensorality is pertinentality. Sensorality partitions. Petition, partition. We've recently derived this relationship between the E and the A. They are inverses, so highlighting that progression throughout. We are demonstrating a unique progression of syllability. Division partitions. Sensorality is divisionality. So now, again, all of this linguistics packages up concepts. Well, they are concepts. But sensorality is divisionality, directly produces the relationship. What is orality to visionality, right? Is vision oral? No. And so again, we're developing our logic till we have this self-contained question, and the answer will be sensorality. Accuracy is virtuous. That's what I was getting at with a virtuoso, right? If you have a piano, some sort of musician, that is a virtuoso, right? They don't miss. They're very accurate. Accuracy doesn't miss. Sensorality is accurate. Accuracy is efficient. Are waves continuous? Last time we talked about continuity. We have this mass, kind of this conceptualization of light as the background, but it's not a conceptualization. You have the microwave, cosmological microwave background. So again, I'm very literally deriving it, and it's like, oh yeah, and it's like the exact word, and it's that thing right there. But that visual or that conceptualization or that picture, that image, is that, again, like the resolution of your TV screen. You go to that channel 3 before there was cable, and it was all like little ants. It was just static, and resolution resolves. And so that background static is the cosmological microwave background. Mass is mass. It's stabilized from that type of environment. And so what is waving? Again, mass moves, and when mass moves in time, it creates a wave. Like that is the visual effect you see when your heat comes off of your stove. And so are waves continuous? I want to say yes there. Again, the questions might be relevant, but the point is to relay the concepts, the logic with the language. Is accuracy efficacious? Right, this relationship between efficiency and efficacy. It's efficient if it does something as fast as possible, as it maximizes work, it minimizes waste. Efficacy, again, does it do what it is trained to do? Does it fulfill its functionality? It's designed to do something, does it accomplish that goal? Ridiculous is absurd. Ridicule is ridiculous. Natural definition. Sensorality ridicules. Ridicule is oral. Again, that's a direct logical statement pulled from the linguistics. Sensorality ridicules, orality ridicules. Ridicule is oral. Ridicule, radical. Radicality changes. Radical is unpredictable. How accurate are predictions? Right? We have error bounds in statistics. Right? Things can only be so specific or so accurate because there's inherent what we've called infinitesimality physically. This bounding of you have an electron, you have some sort of finite dynamic, and you have this inherent immeasurability. And that manifests in statistics as an error bound. How accurate is diction? How precise can our language be? Sensorality divides diction. Orality divides diction. Dictation orates. A curator is a guide. So, got a story for you. A curator and an orator walk into a museum. Yeah, there's no punchline, it's just relating the words again. Context is scenic. Sensorality is oratorality. That is a natural definition. Literally the sensorality, oratorality. So again, we have to work through sensorality because it's literally, again, it's connecting syllability. What does sensorality stabilize? Well, we're building up our linguistics to demonstrate that. And it's not like I'm hiding back the answer. We literally have to work up to the logic. Like I said before, you can conjecture around. Science team certainly has the word forms, but to build the proof, to get there naturally, again, language is very serendipitous. It just kind of happens. Life is serendipitous. You just kind of happen. You're just kind of born and yep, I'm alive now. What do I do? What do I do? But sensorality is oratorality. Sensory is sensational. Satiality is sensory. Sensorality satiates space. Brad, what does satisfying space mean? I don't know. Again, just developing the logic. Sensorality is satisfactory. Because again, we're deriving a definition. And the proof is a demonstration. Satisfactory is adequate. Sensorality equates. Comparison equates. So now returning back to a question that I think I freestyled it, but what is the relationship between base and range? And this word basis is also in there. Basis to range, base to range. But I pose the question, is there a unique relationship between base and range? Which is really the foundational logic for what is a function, right? I just have a little circle drawn, and it's this thing you get introduced to all the time. And I'll say, this thing is a function, this thing is not a function. And what it really demonstrates there is that functions are chronological. That's what I have labeled as the fundamental theory of mathematics. Because when you have A, B, and C as the elements of one set, then 1, 2, 3, and 4 as the elements of another set. If you put 2 into something, and sometimes you get 3 and sometimes into a function, and sometimes you get 4 when you put it into a function, it's not unique. But really what's that demonstrating is chronology. Because functionality is to work. It's a physical, it has a logical, again, all words are logically defined. I'm trying not to use too many adjectives, but I have to make differentiations where you guys have never seen differentiation. But all words, again, are what I would say are logically defined. They have this complete meaning, this essence, this quality. All of what you call mathematics derives from that. So a function is a function. And then they'll say a function in math class. Functionality is functionality. And does something do something, right? Is this thing efficacious? It's designed to do this. It's designed to function this way. Is it working, right? If you ask somebody about a machine, is that machine working? They're asking, is it executing its functionality? And so when we have these circles in A, B, and C, right, just for a specific example, f of x equals x squared, right, if you put in 2, you can get, you're always going to get 4. But you can also put in -2 and you're going to get 4. And so the uniqueness is that you put in a base element and you get a definitive outcome. And so a unique input produces, is that a unique outcome? The input, but see, I don't even like that. The input has to be, the output to the input has to be consistent. If I put 2 into a function, it always has to give me the same outcome. That outcome does not have to be unique. f of x equals x squared. I can put in 2, that equals 4. I can put in negative 2, that equals 4. That's still a function, but the outcome is not unique. And so I had seen verbiage when I just quickly Googled it, that something about unique income, unique outcome. What I just said is correct. But overarching, like what is happening is this demonstrates that functions are chronological. They represent physical processes, and those processes happen in order. Work takes time. Energy requires space. That's my favorite one of the recent theorems. But that's a huge, again, when we naturally derived, is there a unique relationship between base and range? It's the foundation of logic for what is a function. And so another geometric thing that immediately pops into mind that we've derived and discussed is, right, if you have a center point, right, there is no where is here, when is now. Physically is not well defined, it's all relative. But we're in math class, we have a circle, we have a well-defined center. Right? Physically that doesn't exist. All of our geometric objects are ideals, idyllic. But for now, we're in math class proper, and there's a circle on the screen, and we have a center point, a well-defined center point. And so is any point on the perimeter of that circle unique? And the answer is no. And so that's kind of our geometric thing, right? We still have a center, but we can still, in the same way you can put in 2, and you're always going to get 4, but you can also put in negative 2, and you're going to get 4. And then if I have a center, or if I have, I guess, does that even make sense? Does that geometric picture make sense? I have a circle, all of the points on the perimeter of that circle are not unique. Why are they not unique? I've said that before. So now I'm trying to connect logic on the fly. Yeah, but we're discussing what is what is a function, and what is the relationship, or what is the relationship between base and range unique? Because the title of this series is From Rhythm to Algorithm. So that kind of, when I wrote that or stated that, again, all of these statements are chronological, but it kind of, again, rhythm to me strikes me as the base principle, and then algorithm is something derivative from the base. So our derivatives range. A lot of math concepts flying around. Again, just all of this is freestyle deriving, but that is where I finished up with the derivation. But certainly what is the relationship of base to range? Is it unique? If I have a center point and I'm a circle, I'm the center of a circle, right? And I have a point on each side, and they're all equidistant. Because I made a statement previously that, again, that like a center does not have a unique opposite, is what we connecting into. Because each point on the perimeter is equidistant, so it's not unique opposition. But then again, it's more to this iteration is intricate, right? Everything is unique, right? There is a mean free path. If you take a random path, all of those random paths are going to be different. I don't know, a lot of concepts trying to connect in one go, but it doesn't matter. Again, these are just the questions that present themselves from the derivation and where we're at. What is a function? Sensorality, functions, right? Sensorality, a sensor is a functionality. To censor something is to function. Just continuing on with our derivation, that is what I have for now. My rights continue to be violated. It is profoundly illegal. I continue to ask for a little bit of money to eat properly, to sleep properly, and to work. See you on the next one.